So welcome back, and we're lucky enough to be hearing from one of our favourite supporters and sponsors, Automation Anywhere. Manish is going to be talking about embracing cognitive automation to bring structure to unstructured data. A little bit about Manish. He is the VP of Product Marketing for Automation Anywhere, a Silicon Valley veteran with more than 15 years experience in marketing, leading technology solutions spanning from cognitive AI, RPA and mobility. He was previously VP of Corporate Marketing at Mero Networks, a publicly listed company that was acquired by Fortinet. Prior to Mero, Manish helped drive rapid growth for mobility solutions at Aruba Network. He's also held senior marketing positions at Motorola, Symbol Technology, eGain, and Booz Allen and Hamilton. So we're very lucky to have him with us today. I'll hand over to Manish.
Thank you very much. So today I'm pleased to be here and to be talking with you about embracing cognitive automation to bring structured to unstructured data. And in this presentation, I'm going to talk to you about the automation challenge and more specifically how there is a vast RPA and cognitive divide today and how cognitive automation can bridge that gap. I'll also cover some of the differences between cognitive automation and OCR technologies. And finally, how Automation Anywhere can address that challenge for you along with a case study. So most of you are very familiar with this concept of dark data, and it's a very well-known fact that in any given enterprise, only about 20% of the data is visible. And most of the visible data is structured data, data like stored in Excel sheets, databases, and applications. And that's been where RPA has been focused on and so successful. However, 80% of the enterprise data is hidden or dark data, and this includes semi-structured data, which could be invoices, purchase orders, contracts, and so on and so forth, as well as unstructured data, which includes emails, instant messages, images, and videos. Imagine a world where no knowledge worker has to look at any piece of document or any piece of communication just to extract decision-making data. And they're freed up simply to make decisions and handle exceptions. And that is, I believe, something that would be a reality within the next 5 years. And that's the direction where humanity is headed. So a lot of people who have started and had some early success with RPA start looking at cognitive solution as a next frontier. However, there is a big or a giant leap from RPA to using AI or cognitive platform. There is a big divide between them. If you look at RPA has been extremely successful, and it's been growing in excess of 70% compounded annual growth rate and higher, and projected to do so for the foreseeable future. It's because it's been designed for the business users. It's very easy to use. You can create bots in minutes and hours, and in fact, you can operationalize them in days and weeks. We have customers who have reached 1,000 bots within a couple of years, or who have gone from 0 to 500 bots in a year, and who are on a pace of taking a bot from concept to production in less than 30 days. I mean, that's the goal they shoot for. So it's very easy to operationalize, and it's a significantly lower upfront investment. And the initial set of bots, you can get significant ROI in 3 to 6 months. And again, talking about one of the customers, and there are many customers like that who are seeing annual savings of around 100,000 or more per bot they create. And think about when you have hundreds and thousands of bots, you could be looking at savings in hundreds of millions of dollars, and you can achieve that goal very rapidly within a year or two. As opposed to that, the cognitive platforms, on the other hand, are designed for data scientists to use. It requires a significant IT involvement and people who really understand, have expertise in these platforms. It can take months and months, if not years, to develop and operationalize before you start seeing returns. It requires significant initial investment, and it takes you years to recoup that. So there's a vast difference in how people approach moving from RPA, or they need a separate track for RPA and very separate thinking for deploying cognitive platform. Cognitive automation can help you bridge this divide. So cognitive automation, how does cognitive automation bridge this divide? It bridges it by being purpose-built for business process. So in our definition, cognitive automation is designed specifically to automate and improve business processes. And you take out the need for involvement of data scientists or any people with programming expertise, because inside the product, you built in areas of domain expertise. So it learns about different processes and is pre-taught to develop areas of domain expertise in certain areas. And the net result is you can use cognitive automation to develop your bots in weeks and move them in production in a matter of couple of months and get a very rapid ROI. And the cognitive automation is designed that it can leverage its area of domain expertise, or it can go out and leverage cognitive platforms using APIs for areas of domain expertise it lacks and that have already been built into the enterprise. So you can get the best of both worlds. If you've made investment in cognitive platforms and you've developed some solutions, those can be used via integration and API calls, but there's specific areas of domain expertise that can be built into cognitive automation. And that's sort of where we feel the industry's vision should be for cognitive automation. So in terms of AI techniques or skill sets that should be present in a cognitive automation solution, I think our belief is the AI skills that have the broadest set of applicability across the different types of data and database business processes need to be developed first. For example, if you look at machine learning can be applied to many, many different types of business processes, and regardless of the type of data, even if it is structured data based on exception handling, bots can leverage machine learning to learn from how humans handle those exceptions and automate those over time. And the same thing can be applied to semi-structured and unstructured data. The next area, I think, which has a very broad applicability is computer vision. Computer vision not only can apply in terms of understanding the documents that come, a vast amount of documents like invoices, POs, mortgage applications, so on and so forth. But it can be used to understand images and in future videos as well. But it can also have applicability within RPA itself for solutions like automating in a Citrix environment where the information is streamed like an image, and you have to apply the same techniques to understand fields that might move on your screen. So computer vision has a very broad applicability for cognitive automation. And the next area is natural language. Even when you look at both semi-structured and unstructured content, there is some structure there, but there's also unstructured content in both those cases. And natural language skills can really help you understand the meaning of those documents, what is being said. The sentiment can be analyzed is if it has to be another human being. Are they angry? Are they happy? So it has a very broad applicability. And finally, voice and speech has a more narrower applicability where audio communications can be converted, can be digitized and leveraged over there. And then once you have those skill sets, you can combine those skill sets to build different areas of domain expertise. For example, one of the very common examples in our industry is to use invoice processing, and it's rightly so because most companies have a lot of people devoted to processing invoices, which could be in tens of thousands of different formats. If you're a large Fortune 500 company, you can be getting invoices in tens of thousands of formats. And it has been difficult to automate traditionally because it requires a number of different cognitive skills. It requires vision skills to understand the type of document, because the information can move around and people can use different terms for the same thing. Somebody may use a pound symbol to indicate invoice number. Others might use INV. Somebody may spell it out completely, invoice number. You could have balance due or total amount of the invoice. You could have addresses in a vertical format. So there's wide variability, and you need to really apply a number of skills like vision. You need to use logic to really understand if there's some errors in digitizing. You need to apply being able to apply logic like human beings do. When you look at a PO number, and if it is it a 0 or a 8, if it is hard to make out, you look up for that vendor to open POs they have, and that can help you assess whether it's a valid PO number or not. Should it be 0 or 8? So that kind of logical reasoning skill is needed. And finally, ability to learn based on human feedback. When the confidence level in digitizing a document is low, what if we could learn from the feedback, the human corrections made to that digitization attempt? You need to have the ability to learn. So like that, the different skill sets can be combined into different areas of expertise to solve specific business problems. So what are some of the use cases where cognitive automation can give you a significant return? In our experience working with hundreds of customers and engaging with them, we are seeing really good results in several areas. One is one category we call is a category where documents have a large variability in format. And this use case involves invoices and POs. And we can see that by applying cognitive techniques, you can automate up to 60% or more of the workload that was previously being handled by human beings, and you can achieve end-to-end automation or what we call straight through processing, about 60% or plus automation in those cases where you still have a large variability in format, and where people have tried a lot of techniques and have not been very successful in automating that. Another area where we see a lot of applicability is when you have documents with variable number or order of pages. And so a good example of this is mortgage applications, insurance claims, where you can have anywhere from 10 to 60 pages of documents. The order can be different in each mortgage application. The supporting documents can come in different order. Sometimes they are scanned or saved as PDFs and sent in different order, and you need to have the ability to understand which form is located where inside the set of pages, and then intelligently digitize and extract information from those forms. And finally, we are seeing where you have content with small variation in structure and format. So examples could be contracts, where most of the contracts are similar in structure with similar terms, with small edits to the terms. You can get emails or instant message requests to inquiry about what is the order's status of my order, or my customer support ticket. So the language around the request can be different, slightly different in each of these cases, but the intent is the same. So these are some of the cases we are seeing cognitive automation can really help you significantly. So let's take an example of a semi-structured business process and how it can be different from compared to what you might do it today versus what cognitive automation can do. So if you look at today's solutions, typically, often a document comes in, you probably have people look at it, say if you're talking about invoice processing, somebody has to look and classify that document, what type of document it is, and then you might send it to an OCR engine to try and digitize it. And then along the way, you have a lot of human beings involved to process failed documents and validate it against the back office. And finally, somebody, since there's low confidence in OCR technologies, there's always a final review and approval. So there's a lot of humans involved throughout this process to make it happen. And at best, we are seeing 25 to 30% STP that people have been able to achieve, even with most state-of-art solutions. The cognitive solutions, on the other hand, that we have deployed can really help double those results within a period, very short period, 3 to 4 month period. And how that happens is you can eliminate a lot of manual steps along the way. The cognitive techniques are great at understanding and classifying what type of document it is. They are great at validating the data that comes and using logic to correct for small errors in digitizing attempts. And more importantly, they can learn from human feedback, from the corrections made by a human being, and automate that correction process automatically. And then you can combine RPA upfront for extracting the document wherever it resides, whether in the file system or email, and combine it with RPA bot at the end to take the information from a Excel or CSV file or a flat file and automatically populate that information into ERP systems and trigger approval workflow to really significantly increase the efficiency of the process and more than double the straight-through processing rates in these systems. So now let's look at, often we get a question is, how is cognitive automation different from OCR, and what some of the OCR vendors are offering from the intelligent OCR solutions? What the basic OCR does is it is trying to recognize each character that's in the document and trying to digitize that character. And they claim very high, and they're very good at character level recognition, and they often deliver 98 to 98% accuracy for character recognition. But when you start looking at what does that mean for accuracy at a field level, often the accuracy dips because there are multiple characters in a field. If it is a 10-digit field, it can dip below 90% accuracy at the field level. And when you look at a whole document level, your confidence on having it accurate can fall below 50% in terms of having confidence. So you always need human validation when you're using OCR. Intelligent OCRs have come up recently, where some of the OCR vendors say, hey, we have a more intelligent solution which can help you classify these documents, and we have added some machine learning. But I think when we look at the results from these solutions, they are slightly better. You get to a little better accuracy. There is some machine learning, and you lower the human validation needs. But even the best of those tools, we are seeing straight through processing tapped out at most at 30%. 25 to 30% for cases like invoice processing, which are difficult to automate. They might get higher STP in a very narrow use case, but in general, we are not seeing that. The cognitive automation, on the other hand, can use the latest, by applying the latest AI technologies available in the market, that leverages some of the same techniques that are being used from everything from understanding and categorizing pictures to being used in the self-driving cars by Googles and Facebooks. If you combine those technologies, by combining, you can leverage AI to recognize what kind of document it is much more intelligently than any other technology. And more importantly, go beyond recognition to really understand the layout, how is the document laid out, how the different documents differ from each other, and to extract meaning from those documents, apply some machine learning and deep learning techniques to really understand that, along with computer vision technology. And you could use fuzzy logic to really validate some information. For example, if you get some errors in digitizing the address included of the vendor, you could use web services to look up the vendor's address, compare the differences in errors, and conclude that it was an OCR error of 1 or 2 characters. So it's and correct that error. Similarly, for PO numbers, you can, if they're off by 1 character, you can go and validate against ERP solutions. So you can really improve the results significantly by applying fuzzy logic. And finally, you can use latest machine learning algorithms to learn from human feedback. And the net result, what we are finding is you can get almost double the straight-through processing or the automation rate compared to intelligent OCR solutions. So a good way to understand how the cognitive automation work is to look at parallels with self-driving car technology. Just like a self-driving car can recognize differences in terrain and when it's driving, the cognitive automation can recognize the differences in different type of documents and layouts and categorize them much more accurately than any previous technology. Just like self-driving cars can really understand the different objects and the importance of different objects. For example, if there is an obstacle right in front, it's more important to avoid it versus keeping an eye on the objects on the side. Computer vision technology really can understand the layout, to segment the document into pieces and figure out the most important pieces, the pieces that can be ignored versus pieces that need to be paid attention to more intelligently digitize the document. Just like self-driving cars can improve on navigation algorithms that might have, because you might be asked to go a certain direction and you might encounter an obstacle or a blocked road. The self-drive car has to then figure out how to get around that obstacle. Similarly, you can apply fuzzy logic and other techniques to improve the results, regardless of what OCR engine or cognitive technology is using underneath. It could use machine learning to improve those results. And finally, cognitive technology, just like self-driving cars, wouldn't have been possible without years of human beings sitting behind the wheel, ready to take over in case of an error. Cognitive automation can benefit from validation of human beings and learn and build up that area of expertise. So, and that's what Automation Anywhere's IQ-Bot solution has done. It is cognitive automation designed for any business process. It leverages computer vision to really recognize what the document is and categorize it accurately. It leverages natural language process to really understand the intent of the document. It leverages a lot of techniques beyond what OCR does and improves on things to really understand the different segments and blocks and more intelligently digitize the document. It can improve those results by applying fuzzy logics, and it can leverage machine learning as supervised learning to learn from human feedback. And here's an example of a case study. One of the customers where we worked with, they engaged us. They were doing invoice processing. They were using OCR vendor's solution, the best they had to offer, and they were capping out at around 25% of straight-through processing for invoice processing. Excuse me. They deployed our IQ-Bot solution along with our RPA solution to enhance the automation. And within 4 months, our solution was able to deploy, learned from the different document formats, and was able to deliver double the STP. But the beauty of our solution, the cognitive solution, is underlying. You have supervised learning and machine learning, which is constantly developing and building its domain expertise. So the more documents that go through, the straight-through processing continues to increase over time, and you can continue to get benefit and better results as the time goes on. So how should an enterprise approach cognitive automation? I think the path to cognitive automation, I believe, starts with first deploying RPA. And if you haven't deployed RPA yet, we recommend that you go in and pick 2 to 3 high ROI structured processes that you can automate using RPA and get a quick win, and deploy RPA and get familiar with that. And once you've done that, we recommend adding high ROI semi-structured back office processes. We have had instances where people can just go directly to step 2, and that's perfectly fine, because if your pain point happens to be invoice processing or some other semi-structured process, which is a huge pain point for you, you can start right there, and you can still accomplish high level of success. As after you've done that, you've got a few structured processes and semi-structured processes under your belt, then it'll be a good time to move into unstructured back office processes. Again, why we recommend starting in back office is because the hurdle is lower. It's not customer-facing technology, and so you can experiment more because it's an internal process, and you can look at unstructured processes where you might be getting email communications for status requests, or you may want to collect pricing information from a number of websites, and the websites that constantly change. That's an example of a use case that might be applied. And then we are saying, after you've mastered those, then you attempt customer-facing processes, because the hurdle is really high for chatbots and others that you're deploying. And at that point, you can scale cognitive automation enterprise-wide. So in summary, Automation Anywhere believes that cognitive automation will make a real big mark over the next 5 years, and RPA will increasingly evolve into cognitive automation solution where AI is embedded across the board. And we feel, and we make a bold prediction where we say in 5 years time, knowledge workers will no longer need to extract information from unstructured content, which includes documents, images, emails, and more. And these knowledge workers will be freed to do what they do best, which is make decisions and handle exceptions. So with that, I conclude this session. Thank you all for joining me, and thank you for your time.
Thank you, Manish. That was really great. That was very insightful. I really like the analogy of the self-driving car and cognitive automation. Yeah. So Automation Anywhere will be around to answer your questions, both on the chat immediately after this presentation. And they also have a booth in our virtual exhibition hall, where they've got some really great takeaways on the IQ bot and more information on cognitive automation. So please stop by and speak to their virtual reps there. You can also, of course, add Manish on LinkedIn to ask further questions if you can't get him in the chat now. But yes, thank you so much, Manish, and everyone else. I'll see you back for our final presentation. Thank you.